All right, good evening, everyone. Or welcome, everyone, I should say. This is a Department of Computer Science, CECS, College of Engineering and Computer Science here at UCF, showcase for spring of 2025. My name is Mark Heinrich. I'm the Associate Chair for Computer Science here at UCF, and also the Undergraduate Coordinator for CS and IT. My goal today is to tell you a little bit about computer science, both as a discipline and also, of course, computer science here at UCF, and the kind of things that you can expect if you're a computer science or an IT major in our department here at UCF. One thing I'll talk about first is just sort of computer science generally. Computer science, in my opinion, is the right major. So why do I say I want to congratulate if you're interested in computer science and you're listening to this talk. Congratulations for choosing the right major. So that's a very difficult thing to do as an undergrad. Why do I say it's the right major? Well, don't listen to me. We can listen to the U.S. Bureau of Labor and Statistics. That's what this chart is about. And it shows the current job openings in the U.S. in STEM, which are the high-paying jobs in the U.S. And it's a little bit of an eye chart, but you can see that 65% of the chart is blue, and that's computer science. There's a little bit of computer science almost in every kind of solution to all kinds of problems that are out there. And you're seeing that in the job market. But that's the current job market. So I got another little chart, and this one is job growth. So how that's expected to change as we go forward. And you see that it's even a bigger slice of the pie. 76% is computer science and IT, the computing disciplines. So that's why I say CS is the right major. Certainly one where you can expect to have a job when you graduate with your CS degree. A little bit about computer science here at UCF. So computer science is a pretty large department. We have about 5,400 undergraduate students and around 800 graduate students when you combine all of our graduate programs together. So you get about 6,200 students. The programs have a pretty long list. It looks almost like a college, but we're just a department. We have a Bachelor of Science in Computer Science and a BS in Information Technology, and those are the two that I'm going to be discussing most about today, and probably the ones you're most interested in hearing about. I'll talk a little bit about the master's programs when it comes time to talk about the curriculum. And I know it's a little bit early in the game, but it's never too early to start thinking about whether you may want to stay for grad school. We do have, of course, an MS in computer science here in the department. We also have a master's in computer vision, which is one of the only computer vision master's programs in the country. We have a master's of science in cybersecurity and privacy, which of course is a growing area. We have a master of science in data analytics, a master's of science in digital forensics, which is popular with law enforcement. Joint with the College of Business, we have an MS in fintech, and that started just a few years ago, covering areas like crypto and things of that nature. And of course, we have a PhD both in computer science and a PhD program in big data analytics that is joint with math, statistics, and data science. So it's a big effort here, and that's one of the themes of today's talk I want to sort of leave you with is sort of all of the energy that's going into the CS program here and how it sort of manifests itself in different ways. I wanted to talk a little bit about CS against as generally, but then sort of also dive into more about what's going on here at UCF. So first, what is computer science? That's what you're here to learn something about. And typically when I talk about this, people will say something like, oh, I know that one. Computer science is programming, right? And that's not wrong, but it's also not completely the entire story, right? There's a little bit more to it. In fact, I have just a bulleted list here of areas of study within computer science. It turns out computer science is a really massive spectrum of topics. It's a really wide tent, so to speak. For example, topics like bioinformatics and system biology, which is the intersection of computer science and biology, where they're doing things like drug discovery and the human genome, and which is leading to sort of treatments for disease and cancer and things of that, small things like that. There's computer architecture, which is my own personal area. So I build large-scale supercomputers. Wait a second, that sounds like hardware. I thought computer science was software. right? So it turns out that there's a significant hardware component in computer science as well. And my area, computer architecture, happens to live at UCF and in many universities in the computer science department. Computer graphics, which also has a hardware component, and also touches on things like video games, which I'm sure no one is interested in. So computer graphics is a big area here at UCF. Of course, computer security and cybersecurity, digital forensics. I mentioned those graduate programs, computer vision. We have a Center for Research in Computer Vision in the computer science building right here on campus. I mentioned the master's program as well. Databases, that's also data analytics. And I mentioned that program as well. So big data analytics is a big area in computer science. We have image and video processing there, and of course, machine learning and AI. I kind of bolded it because that's a big topic area that everyone's talking about these days with Chat GPT, among other things. But it's not just Chat GPT. AI and machine learning is used other places. If we've all been on Amazon and went to buy something, and you scroll down a little bit, it says people who bought this also bought this, right? So that's machine learning. The fact that your car in a few years' time is not going to have a steering wheel. That's machine learning and AI, right? It's like the world is a scary and changing place. And the center of that effort is right here in computer science. UCF, half our building already is probably experts in machine learning and AI. I'm not one of them. But we have a hiring initiative to hire even 15 more faculty on top of the ones we already have, right in this same area, because it's touching so many different parts of campus. Um, what other areas in computer science? Networking, of course, mobile computing, things like your cell phone, parallel computation, getting back into sort of my area, sort of cloud computing, Amazon Web Services, things of that nature. I'll skip one. I'll go down to theory of computing. So, theory of computing is the mathematical parts of computer science, algorithms, the parts of computer science that sort of sprang out of math departments 40 or 45 years ago when CS was founded as a discipline. And then the bottom one, we have virtual reality, augmented reality, the sort of Pokemon Go or the headsets, right? Abbreviated VR, AR, mixed reality, MR. They got tired of putting a letter, so they just say XR. And human computer interaction. There's a huge effort at UCF here, including faculty here that are members of the National Academy of Engineering, that are leading up our efforts here. And I did skip over one. Oh, software engineering, programming. Like, there it is, programming, right? We're talking about programming. So it's there, but it's just one of many topics that you can be a part of and learn more about as you go through your degree program here at UCF. This is a little bit of a busy slide, but if you look in the right-hand side of the slide, you will see a bunch of companies. And these companies, in a world that's not producing enough computer scientists, and the fact that UCF produces about 550 bachelor of science degrees in computer science every year, which is among the top number of any university in the country. In a world that doesn't produce enough computer scientists, what happens? Well, all the people that are looking to hire computer scientists come here every semester. So, in fact, the business card of the Google recruiter is sitting here on my desk, and they're looking to hire more people. They know the strength and quality of the UCF computer science program, and they're bringing back their alumni that graduated from UCF with them to sort of recruit the next generation. So that's a little bit about the CS areas. If you look at the department here, this is a little bit of a faculty focused slide on the left, and sort of some awards that faculty have won. The National Academy of Engineering, I'll draw some attention to because it's considered sort of the highest honor a faculty in engineering computer science can achieve. So we have 3 NAE members on our faculty. And if you look at the bottom 3 bullets, these are awards, NSF Career, and the 2 below that are awards given by either NSF or Department of Defense to young faculty members just starting their career that show exceptional promise in their research area. And to have 11 members of our faculty who have won that award, again, just kind of is a tribute to this sort of energy that's going to be infused into the CS program here. If you look at the right, it talks a little bit about ranking. There are some rankings that don't have a lot of merit. I'll let you maybe figure out which ones those are. I just wanted to point out csrankings.org, which you may not have heard of. It's sort of an independent effort to look at the places where the best work in each area is published, and then in a sort of brand independent way, throwing out biases. It just says which are the current universities that are publishing in those places, right? So every year there's the best venues for publication and which universities are publishing there, and it does a rankings based on that. And if you do that, UCF is ranked number 4 in virtual reality in the country, and number 8 in computer vision. And you see those other rankings, number 22 in computer architecture, which is my area. That's not because of me, but we have other excellent researchers in computer architecture. And I mentioned AI before, and so you can kind of play with that yourself and sort of combine categories because the AI, computer vision, machine learning category were ranked number 23. So maybe some surprisingly high rankings for UCF, but again, this will be a theme of today, a little bit of surprise, and I'll maybe give some reasons why that might be later on as well. If you're a CS major here and you graduate, you can go on to careers, obviously in industry, perhaps in research, maybe have a career in entrepreneurship. And I'm a two-time entrepreneur myself, and we infuse some of that into our senior design program that I'll talk about later. I just highlighted here on these slides 3 alumni that won from each track. So Alan went to the industry route. He's the 4th ever PhD from UCF. And UCF, by the way, has the oldest computer science PhD program in the state of Florida. So another reason why, if you're interested in computer science in the state of Florida, you're really in the right place. And so Alan was our 4th ever PhD. He went on to become a VP of engineering at Google, and he's given back to the programming team and helped support that. I'll talk about the programming team in a moment. So I just want highlighting Alan here. He also is a pretty interesting guy. If you look at the bottom left, he holds the Guinness Book of World Records for the highest free fall human jump. So he jumped from the stratosphere, not the building in Vegas, but the actual stratosphere. So he's got this cool article, Why I Jumped. Cool guy. Omar, he was a researcher here, PhD and PhD student. He went on to become the VP of Applied Science at Twitch. If you don't know what Twitch is, ask your kid. And he actually left Twitch, though, a couple years ago now to do a startup. So he's also maybe an example of both someone who did the research track for a while and now is doing entrepreneurship. And I'll point out David Bettner here. He was a CS undergrad, and he was the developer of one of the first viral iPhone apps, Words with Friends. Perhaps you've played it. So it's coming right out of our undergrad program. All right. I mentioned the programming team. Another example of sort of maybe surprising strength in the quality of the UCF computer science program. Simply put, it's a lot of words here, but UCF has the best programming team in the country. The programming team is like the math team in high school, where you're working on math problems in a timed fashion and you have to get so many right in a certain amount of time. Same thing for these programming type problems. It's sponsored by ACM, the Association for Computing Machinery. And that's the professional organization of computer science, like IEEE is for electrical engineering. And so it's structured in regions. So there's a regional competition. Southeast region is our region, and then there's a national competition, and then there's a world competition. So for 43 years in a row now, UCF has finished either first, second, or third in the Southeast region. That is the region that includes all the schools in Florida, plus Georgia Tech, Duke, Clemson, that whole region. Many of the years, by the way, I think 34 of them, UCF has finished first in the Southeast region. Some years we've finished first, second, and third because there are multiple teams. And if you want to get involved in this, in the programming team, you can kind of do that at whatever level you're most interested in. You can do it at the highest level. There's varsity teams, there's junior varsity teams, there's freshman teams, there's teams who like ice cream. I'm not sure. There's a lot of teams. And I think I have on the slide, yeah, the where we finished in the last regional finals, we finished first, third, fifth, and sixth. So we see that I think Georgia Tech finished second in that particular finals. This final, they actually had a super region. So after winning the Southeast region, it's kind of like the college baseball World Series. So they did a super South region, and UCF also finished first in that region, beating like UVA and UT Austin, and where they're moving on to the World Finals. The UCF programming team was the 2017 U.S. champion, the 2018 North American champion. In 2018, when they were the North American champion, we finished 10th in the World Finals. The top 9 teams were all Russian and Chinese. So you have the 9 Russian and Chinese teams, then you have UCF, right? Best team in North America. So again, why are they good? By the way, because they work at it. They're here on Saturday mornings, 9 to. It's like being in the marching band. Like you put in the effort. You're working on becoming better at algorithmic thinking. And we have the faculty that are putting in the energy, and we have a bunch of smart students, and together it's a pretty good combination. Not to be outdone, there's also our cyber defense team. Similarly to the programming team, it's another sort of set of competitions that focuses on cyber defense, and there's national championships, and UCF has actually won the national championship in cyber defense 6 times, which is the most of any university in the nation, including the 2024 reigning national champions. And you can see that on the slide. They finished national champions 14, 15, 16. By the way, in 17, 18, 19, they finished second. So we almost disbanded them because, it's embarrassing. But, they came back and they won 3 more national champions. So I guess we'll let them stay. Again, faculty and students coming together and producing amazing things. If you do you want to do interested in research as an undergraduate, can you do that at UCF? Of course you can. There's UCF, is a big place, and it affords lots of opportunities to students. You just have to seek it out. Um, you can do research as an undergraduate, both sort of formally and informally. So this is one of the more formal methods. So there's a National Science Foundation grant called the REUs, the Research Experience for Undergraduates. And it brings people from all over the country onto a campus in the summer, and then the local university that can participate as well. There's an REU in computer vision right here at UCF. It's been going now 37 years, I believe. It's the longest running REU in the country, right here at UCF, in this area of computer vision. Our current chair, Don Laturga, is actually partnering with a former student, Albert Monero, and he started a company called Limitless Solutions that you may have seen. They develop sort of 3D printed prosthetic limbs, mostly arms, for children who need them. And again, it's a testament, I think, to here's another problem that where there's computer science and machine learning involved in sort of better calibration and configuration of the limbs to make it sort of more specific to the person who's wearing them. It turns out that it's not just a mechanical engineering problem; it's also a big computer science problem. So it's a great example of how CS is sort of touching all these areas of research in some way. And that's a new REU that's starting this summer here at UCF. You can also do less formal things. I mentioned just go knock on the door of a faculty member, right? And just I know you have to actually go talk to someone, but you can go knock on their door and just say, hey, I'm interested in what you're doing. Most faculty are going to talk to you about that and say, why don't you come by my group meeting 3 o'clock on Thursdays, and they'll probably pair you up with some of their existing grad students, and you're off to the races. You're doing research for that lab. Just briefly, since we have another 90 minutes or so, no, just joking. But you can look up the UCF flowchart. This is not a secret. We're not keeping it a secret. You can just Google UCF computer science flowchart. You'll get this flowchart. If you're interested in it and you come here, I tell all the students, print it out, put it under your pillow, sleep on it. This is all the courses you need to graduate in computer science at UCF, aside from the GEP courses, the ones that everyone takes for every major. And so I just want to point out 4 things here real quickly. The top left, you don't have to have any required experience, any previous experience in computer science to be a CS major at UCF. So if you've never programmed before, I say welcome to UCF computer science. It's okay. If you do have programming experience, we'll start you in that shaded course you see there, COP 3223. If you have no experience, we'll start you in the course above that, 2500, and you'll get the experience that you need to be successful in 3223. If you took a APCSA in high school, and got a 3 or better, you will automatically be placed into that shaded course. You don't have to take 2500. If you kind of learned on your own, or you took APCS principles, which we don't directly take, you can take our completely optional placement test, 25 multiple choice questions, language independent. And if you score well enough on that test, you'll also start in the shaded course. So the point is we sort of start you in the right place where you'll be most successful in the program. And we're not mixing inexperienced with experienced students sort of day one, which usually makes the inexperienced students feel like they don't belong. And it's not the case, right? You just need to gain that experience first, and then you'll be fine. If you look at the top center of the flow chart, you'll see the foundation exam. This is an exam that we give after you take CS1, COP 3502 on that chart. That's our hardcore data data structures and algorithms course, taught in the C language also. Whether we teach multiple sections of that course, sometimes you'll take that course at other places. The foundation exam is given once per semester, and it just tests your knowledge of that material in CS1 to make sure that you have mastered it, so that you can be successful in the rest of the program. We give the FE once per semester, the first Saturday of every semester, and you have three chances to take it and pass it. If you don't pass it after the third attempt, then you have to choose a major other than computer science. Um, but all the previous exams are online. Pay attention to CS1, and you'll be fine. That foundation exam, students get nervous about it, of course, but you could even say maybe they don't like it. But the ones that don't like it, the very same ones, after they pass, they love it. And so why is that? Well, let me jump to senior design 1 and 2 on the right-hand side. You see that sequence. That's the capstone sequence. Your last two semesters where students work in small teams on realistic and meaningful problems, and to show their skills, show what they've learned. How do I know they're realistic and meaningful problems? Because we have companies come into the class like Northrop Grumman, Lockheed Martin, NASA, Orlando City Science Center, Red Lobster, other faculty from across the campus. Everyone's got a computer science problem, and they usually start their pitch with something like, "I have a problem." And they talk about these different things, and students get to hear like 50 or 60 different projects, and they get to rank the ones they're most interested in working on, which ones they want to spend 2 semesters on. And they get that cool experience of working on a realistic problem. By the way, that senior design instructor, if we put ourselves in that class, is going to say this is a big problem in a small team, and everyone's got to do their part, or the project's not going to work. No one's going to have time to do the part, that someone else isn't doing because they're too busy doing their part. And oh, by the way, the project has to work or you don't graduate. It gets really quiet in class when that happens. And if you imagine you're a student in that class and you look around, who do you think you want to have in that class with you? And the answer to that is people that pass the foundation exam, right? So that is why the same students love it, right? Because it's sort of, they know that if you're in this program, you know what you're doing. Employers know that if you're in this program, you know what you're doing. They know what it means to be a UCF computer science graduate. And it's sort of, it's part of what makes CS so strong here at UCF. So we have, I said four things. We'll start you in the right place. We have the foundation exam. We have the senior design. The fourth and last thing on this slide is the bottom. It's one big box and it just says 18 credit hours. That's 6 courses, tech electives. This is the largest number of tech electives of any major within the college. Some have 2 tech electives, some have 1, some have this many. Um, so you get to do something really cool. It's, in my opinion, the best part of the degree, and it's different even from other computer science degrees around the country as well, which are more prescriptive. You get to tailor your degree toward your interests. And this is important because remember that slide I showed, this one, right? With all those bullets on it. What are all those tech electives? There are courses in all of these things, right? So you get to decide, hey, you know what? I do want to learn something about machine learning and maybe a little bit about virtual reality or computer architecture or computer, whatever it is. So you can get yourself some breadth, right, in an area or across a couple different areas, some depth within one area, and really tailor the degree toward your interests. Because it's probably the case that no one person is interested in all of those areas, right? You probably have some specific interests, and our program lets you do that, which is really cool. The other thing that 6 electives lets you do is uh, back to the idea of master's degrees, which I said I'd talk about later. So we have a BS to MS program that's accelerated bachelor's to master's program that lets you do something you never get to do in life, which is you get to double count things. So every master's degree is 10 courses. A full load for a master's student is 3 courses per semester. So if you planned out, and there's no summer courses in master's degrees, so if you planned out your master's with 3 courses a semester to do 10 courses, you'd go like three, three, 1. It's a mess, right? It's like too many, it's too long. So The BSMS is designed to fix that, and you can take up to four of those master's courses, those 5,000 level graduate courses, and take them while you're an undergrad, and they count as four of your tech electives right there in the flowchart. And they not only count toward your undergrad degree, those courses also count toward your grad degree. Amazing miracle. So when you graduate, you're not left with 10 courses, you're left with 10 minus 4 equals 6 courses. And now we can plan out your master's degree, three, right? So you just get 2 extra semesters, and it's a really smart way of, if you're interested in the graduate program, it's a really smart way of doing it. In my opinion, I'm a professor, so I like to profess. Um, rather than if you, especially if you're ahead of the game, sometimes people will come here with AP credit or IB credit, or they've come from a state college and they already have a lot of the math, or they're ahead in the GEP. And then they start getting creative. They're like, oh, I'm going to do like a triple major in CS, econ, math, 17 minors. I call that going wide. And sometimes there's a good reason to do that. But a lot of times it feels like you're just sort of collecting things. And my advice in general is don't go wide, go long, right? You already chose the right major, remember? Congratulations. So, given that you already chose the right major, go long. Leave UCF in 4 years, not with a BS in computer science, but with an MS in computer science, the right major, right? You'll get a 20K salary bump. You'll get an extra summer to get maybe you've had an internship, but you'll get maybe a chance to get the internship, which leads not to just a job, but maybe to the job that you wanted. And it's a chance, of course, to learn, to get more breadth and more depth, even beyond what you're getting in the undergraduate, because there's so much more to learn. And you get to do all of these things for just sort of one more calendar year. So the MS, I think, is one of the best deals going. A little bit about the IT program as well. IT and CS start out in a similar way. So we have the same 2,500 and Intro to C and Computer Science 1 progression. But there are fewer electives, and there's sort of more required courses in IT, in things you might expect from an IT program, like networking and security and enterprise computing and system management and things like that. So there are fewer electives. And more focus on security. If you are interested in cybersecurity, you can do that from either the CS or the IT major. It's my most common question, so I just wanted to say that here. In CS, you don't see those security courses as much. You see the one on top there, security and computing. But the other ones would live in those tech electives I mentioned. You would take your 6 tech electives and target them from the networking and security area, and you can do that just fine. IT has more of the required, and you could do the same on your 2 electives. Um, if you said, hey, what should I do? I would ask you a question in return, and that question would be, where are you in math? And it sounds like maybe a weird question, but if you go back to the CS flowchart along the bottom, you see that Calc 1 and Calc 2 are required. And then there's 2 more math courses at the top right. So it's Calc 1, Calc 2, 2 more math courses. In IT, you might see at the top left there, the highest level of math is pre-calc. So if you're starting out in college algebra, it's not that you can't be a CS major, you can, but it's a longer road. You got to do calc. I mean, you got to college algebra, then trig, then pre-calc, then calc 1, then calc 2, then 2 more math courses. Whereas IT, you can kind of stop that sequence at pre-calc and focus on the technical courses from there. So if you're already calc ready, or even have some calc credit, my advice would be to do it from the CS major, because the salaries are a little higher and there's a little um, more opportunity to, if you change your mind, you might see something shiny and choose one of those other areas as well. But you can do it from either CS or IT. This is kind of my last slide, but I've hopefully talked about most of these things as kind of a checklist for me. So I've mentioned the number of students we have. We're a large entity. I talked about the foundation exam. We are fully accredited by ABET, which accredits all the engineering programs at UCF and in the US. You can do internships for credit now in both CS and IT, and you can do one of your summer internships and count it toward one of those tech electives I mentioned. Of course, you can do undergraduate research. You can get involved in the programming and cyber defense team, but there are other teams. For the students out there, my final kind of advice to you is you would be remiss if you came to UCF, went to class, got an A, and went home. You could do that anywhere. Um, you're at a tier one research university, so take advantage of those opportunities that I mentioned. So if you don't want to be in the programming team, cyber defense team, that's fine, right? But there's other things. There's the ACM. We can get involved in that professional organization. There's an AI club. There's hackathons, night hacks, other extracurricular opportunities. Um, CS is a show me discipline. I like to say, like, don't just tell me you're interested in computer science, like show me. So I mentioned before I started two companies. If I was hiring you, I would um, ask you, tell me about a large project that you worked on outside of class. And it doesn't have to be necessarily outside of class. You could tell me about your senior design project or something you're showing me something that you've done, and you're talking about it, right? And I can sort of gauge, like, are you enthusiastic about what you're doing? Do I want this person would this be a good person to work with? That's what I'm trying to gauge, right? I have a stack of resumes here. There's like 100 of them. They all have 3.7s. They all went to class, got an A, and went home. Which one am I hiring? Right? The answer is the one with the best story, right? So, what's your story? Figure that out. In fact, don't even write your resume until you know the answer to that. And then everything that goes on your resume should reflect that story of like what you're trying to show. Um, And so my advice to students is do that. Get involved, break out of your comfort zone a little bit, go knock on doors, participate in these things, develop your story. It's also a way to make UCF, which is a big place, seem smaller, right? And more tailored toward you, right? And you sort of easy, it's a good way to find friends and sort of find your people, right? So that's my advice to the students. Uh, find your people. All right. My name is Mark Heinrich again. That's there in black and white. My email is easy. My last name, Heinrich at ucf.edu. If you do have further questions about something that I said or something that I didn't say, feel free to reach out to me. Let me know that you watched this and you had a question, and I probably know the answer. Or if I don't, I can find out the answer for you. And that's all. Thank you for your time today, and thank you for your interest in UCF computer science.